Topic 9 is about international environmental problems. It is hard to solve the international problems because of many reasons. The first one is because of free riding issues among the affected countries. Second is because we don't have an international government to govern the whole world. Another reason is because different countries will have different interests, so it is harder to get people to cooperate. So in one country, the government can actually enforce the solution. For instance, the government can implement emission trading scheme. Internationally, we don't have anyone to enforce with some policy or any policy in this area. So if you look at the image on the right side, so this is the case of Indonesia forest fire. So this is the examples of transboundary of environmental pollution. This pollution basically can affect or affecting a few countries, not only Indonesia, Malaysia, Singapore, and Brunei. So this problem is a very common international issues every year. Okay. Let's have a quick question. If you look at this image, this is the examples of Sumatran rainforest. So they are having a higher rates of deforestation. So in this case, do we have to concern about these problems? What do you think about it? Why do you have to be concerned about it? Or why not? So we will discuss this question during the class time, okay? This is our interdependent world. The world map is divided by some lines, but environment doesn't really care about the border or the line. In many cases, pollution crosses the lines. For example, air pollution in Indonesia is actually affecting Malaysia and Singapore. This pollution coming in without us doing anything. This is exogenous gift of a bad variety. So there are also many other stories. For example, if you are in South Korea, we are receiving air pollution from China. If you are in actually Canada, we are receiving acid rain from the United States. If you are in Norway or Sweden, we are receiving acid rain from the United Kingdoms. So how can we solve this problem? This is the topics of today's class. In some cases, for example, Singapore will give money to Indonesia so that Indonesia can reduce some pollutions. Or perhaps in certain cases, they also will have some negotiation. But it is very challenging because the source of pollution isn't in our country. Okay? Externality are actually transboundary. The global environment or atmosphere is the examples of public goods, while the pollution is the examples of public bad. We are sharing global commons or global atmosphere, but we don't have global governments. We do have actually global institutions like United Nations, and they also have some environmental section, but we don't have a very strong global governments to enforce any particular global policies. We also have some global or international environmental agreements, and we will discuss about it today. Okay, so if let's say we are talking about a few countries involved, cooperation might be possible. So it is like the Caucasian solution, but in this case, it is between countries. But when the number of participants growing, it is difficult to negotiate, right? So some countries have made attempts to actually solve the environmental problem with varying success. We will apply the concepts of game theory in the case of international environmental problems. So it is actually a powerful technique to analyze the interdependence of behavior. For example, where pollution spill over national boundaries, expenditure by one country on the pollution abatement will actually give benefits to abater as well as the others too. So if the country choose to do nothing, it can actually benefit if others do. So the benefits, or we call it payoff, to do pollution control or not doing it depends not only on one's own choice. Okay, so let's start with a simple game. So here we have two players, countries X and country Y. So initially, we will have single binary simultaneous choice. Okay, so these two countries will have two strategies. Strategy 1 and strategy 2, whether they want to abate or not to abate. So the first letter here is actually the payoff for country X, while the second letter is the payoff for country Y. So we will explain the examples of this game theory in the next slide. Prisoner's dilemma. Many global problems are like prisoner's dilemma. It would be good if they can cooperate. But each country has an incentive to divert from cooperation and be selfish, and therefore the idea for agreement might be not possible because all countries will go for their best strategy. So let's imagine here we have two countries, country X and country Y. So these two countries have the option to pollute or to abate. Okay, so if let's say both countries choose to pollute and pollute, their payoff is 0 and 0. If both of them choose abate and abate, their payoff is 3 and 3. So the total benefit is actually higher, which is 6. So if country X were to pollute and country Y abates, so basically country X can get the benefits of abating done by Y, which is 5 and minus 2. So how to get this number? Okay, so let's assume here that the abatement cost is actually 7, and this abatement cost or cost of reducing the pollution will give the benefits of 5 for both countries because abatement is actually a public good. So in this case, definitely when Y abates, so X will get the benefits of 5, while for Y, because Y is the one who is doing the abatement, so the cost is 7 plus the benefits of 5, so Y will get minus 2. Okay, so the same case for Y as well. If let's say Y choose to pollute and X abate, so definitely Y will enjoy more benefits compared to X because X has to incur the abatement cost. Okay, so how would this game be played? We can think that what if Y wants to pollute? So in this case, Y wants to pollute. So X can choose between 0 and negative 2. So definitely 0 will give a better or higher benefits. So X will choose pollute. So what if, let's say Y wants to abate? So X will choose 5 over 3 because 5 will give a higher payoff. So no matter what Y does, X will always choose to pollute because pollute will give a higher payoff. Okay, so pollute is a dominant strategy equilibrium because this is the best response of each country, and whatever the other country is doing, so pollute is always the best response. Okay, so pollute is also a Nash equilibrium. Why? So in other words, we can say that each country is playing its best response given what the other is doing. Okay, so if players play non-cooperative, so basically we can expect these two countries will choose pollute and pollute. And the last point is that, so basically, if let's say they choose to cooperate, so they will get the total benefits of 6. Basically, their total benefits is higher. However, abate is not a sustainable equilibrium. Why is that? If let's say we look at from the points of view of X. So if X abate, so the payoff is 3, and if let's say X pollute, the payoff is 5. So 5 is actually greater than 3. So X has the tendency to divert, to choose pollute. The same for Y. So if let's say Y abate, the payoff is 3. If let's say Y pollute, the payoff is 5. So basically the payoff for polluting is higher. So definitely both players will have the tendency to divert from the equilibrium point. Cooperation. This is just a repetition of what I have explained in the previous slide. So in this case, cooperation is not possible because there is an incentive to cheat once the agreement has been reached. Okay, so abate and abate is the best solution, but it is not sustainable because people have the tendency to divert from the solution. And it is quite common for the environmental problems. For instance, if let's say company or country A has done the abatement activities, so country B can enjoy the benefits of abating by not doing anything. And there is no global governments to enforce an agreement. So that's why everyone can do whatever they like. Okay, agreement between nations should actually be self-enforcing if they are to be sustained, because we don't have global government, so everyone should do by themselves. Everyone should actually doing the abetting activities. So it must be in the participants' own interest to become or to join the agreement so that we can make sure that our world is sustained. Okay. Another types of game is called a single abater. So in this case, the Nash equilibrium is that one country will pollute and the other one will abate. So in this case, the equilibrium is 5, -2. And given the X dominant strategy is to pollute, therefore, Y will always abate. So how can this be possible? So let's look at it from the X point of view. Okay, so if let's say X wants to pollute, so the payoff is -1. If let's say X wants to abate, so the payoff is -2. So X will compare between -1 and -2. -1 will give a better or higher benefits. So X will always pollute regardless of whatever Y is doing. Okay, so we can say that the dominant strategy for X is to pollute. So now, if let's say Y wants to pollute, so the payoff for Y is -4. If let's say Y choose to abate, so Y will get -2. So in this case, Y knows that X will always pollute. So Y have to compare between -4 and -2. Which one will give Y a better or higher benefits? So Y will choose -2. That's why the Nash equilibrium is 5 and -2. So for some pollution problems, we might expect abatement leadership from countries who are facing larger local impacts from the pollution, because they are the one who will do the cleanup process, because the other countries may not care about it. So since they are facing or they are having the larger impacts or larger pollution, so they have to do the cleanup process, even though the others will get the benefits from doing nothing. Okay. We also have another types of games called assurance games. So in this case, two countries are contributing to a global public goods. For instance, we are talking about conservations of biodiversity or reintroductions of species into our ecosystems. So let's start with Y. If let's say Y choose not to contribute to this biodiversity, so what will X do? So X will choose between 0 and -8. So 0 will give a higher payoff. So this is the first equilibrium. What if Y choose to contribute? So X will choose between 0 and 4. So X will choose 4. So basically in these types of games, we will have two Nash equilibria, 0, 0 and 4, 4. So if let's say we play a single short game or just play the games once, so it is quite likely to be contribute because there is no incentive to divert from 4 to 0, 0. So the result is actually quite stable here. Okay, so if this game is repeated, we will have even more chance to get contribute and contributes. If we played the games one time under the prisoner's dilemma, the outcome is pollute and pollutes. So let's imagine if this game is repeated or played many times. So it might be actually possible to get away from pollute and pollute equilibriums. So the whole goal is actually to get here, which is 3, 3. So this is actually the purpose of climate change agreement, which is to reduce pollution and enjoy more benefits. So how can we get here? So definitely we have to think of a strategy, and the strategy will be explained in detail in the next slide. Grim trigger strategy. Let's assume we have two countries, X and Y. Imagine each country will play their own strategy. Okay, in the first year of the games, the country will, for instance, abate. So this is the strategy, that is to abate. If in the previous year every country play abate and abate, then the country will happily keep abating. However, if the country observed that in the previous year the other country cheated, polluted, and did not abate, then the country will forever after pollute and did not abate. So this is called as the grim trigger. If the country observed that the other country cheating, that is the trigger for a grim strategy forever punishing the other country by polluting. Okay. Now, suppose country X is using this strategy. What is this strategy? Abating. Is this strategy a base response for the Y, for country Y? So should country Y abate as well? Is it the best response for Y? Okay, so basically Y will have two options, option 1 and option 2. Okay, what is option 1? Option 1 is to abate, while option 2 is not to abate. Okay, so for option 1, this is the payoff for abating. So country Y will get 3 every year. While if let's say country Y don't want to abate, so country Y will get 5 for cheating in the first year while the other country is abating, while in the coming year or following year, country Y will get nothing. Okay. Now, if you look at option number 1, so definitely in the present year, country Y will get 3. However, in the coming year, we have to discount the payoff with the discount factor as well as the discount rate. Okay, so how should the country Y choose between option 1 and option 2? Which one is bigger? Okay, definitely it will depend on the R. So what is R? The discount rate. Okay, so basically I will explain on how to find the R in the next slide. So in this case, basically, if let's say our R is less than 1.5, we can actually maintain or get abate and abate as the sustained equilibrium. So what does it mean? It means that if let's say country Y is not that impatient, so option 1 will be more attractive for country Y. Okay? How to find the R? We will use the formula of sum of infinite geometric series. So we have A plus AX squared plus blah blah blah, and we will get A over 1 minus X. So here our A is equals to 3. So we will receive 3 every year or forever. So our X is equals to 1 over 1 plus R. This is our discount factor. Therefore, the sum is actually equals to our A here is 3 over 1 minus X. X here is 1 over 1 plus R. So we will get 3 over 1 plus R minus 1 over 1 plus R. And if we cancel this off, we will get 3 multiplied with 1 plus R over R. So definitely Y will abate if 3 multiplied with 1 plus R over R is actually bigger than 5. Why 5? Because this is the payoff of cheating or not abating. So when you rearrange it and find the value of R, you will get R less than 1.5. Okay? So Y will abate if R is actually less than 1.5, or else Y will pollute. Summary of the repeated scheme. So climate change cooperation is basically needed over a long time horizon. This is just like our repeated game. So grim trigger style strategies tend to encourage the countries to cooperate. So repeated interaction can therefore potentially result in efficient outcome. However, in practical, it is actually difficult to be implemented because is it really credible that countries will punish the offender? So do they really care about the punishment? If let's say you are saying that, well, your country wanna pollute forever, who cares about it? They also may want to pollute forever. Okay? Okay, let's have some discussion here. Let's assume that the world consists of two countries. We have country X, which is a poor country, and country Y, which is a rich country. So the total benefit, which is B, and the total cost, which is C, of emission abatements are actually given by the function below. So the first one is the benefits of emission by country X, the benefits of emissions of country Y, cost of emissions of country X, and cost of emissions from country Y. So the first question is that let's find the non-cooperative equilibrium levels of abatement for country X and country Y. Okay, so we will discuss this question during the class time. Second question, find the cooperative equilibriums for both country. And next, calculate the utility level enjoyed by country X and country Y in the non-cooperative and cooperative solutions. So does the cooperative solution deliver Pareto improvements for each country? The next question, find the privately optimizing level of abatements for X given that Y decides to emit at the levels of emission that Y would emit in the cooperative equilibrium. Okay. The last question, suppose country Y will do whatever which is the non-negative amounts of abatements is required to make the combined world abatement equals to the combined total under a full cooperative solution. How much abatement is undertaken in both countries? So you have to compute the solution. Okay? Games with multiple players. Basically, we are extending our games to more than 2 countries. So definitely, cooperative solutions are harder to achieve when we are dealing with many countries because there is an increased incentive to free ride, and we also will involve with a larger transaction cost. So the image on the right side is basically the climate change negotiations. So according to Todd Stearns, which is the US climate negotiator, after the Copenhagen round, basically you cannot negotiate in a groups of 192 countries and to achieve one solution on the climate change. It is actually very hard. Universal treaties typically have one or two qualities. The first one is that they don't ask countries to change what they are doing right now. So basically they are happy to sign on. Or they ask for fundamental change in behavior, and then they have lack of monitoring systems and sanctions provisions that are credible. So basically there is no changes in the current situation, especially with regards to environmental problem. How effective are the international environmental agreements? So in order for us to know the effectiveness of an agreement or of a project or programs, we have to construct a counterfactual estimations. In other words, we have to compare before interventions and after intervention. We also can compare business as usual with something after the interventions. In this case, we have to compare the Nash equilibriums, or we call it non-cooperative solution, with the cooperative solutions. So to be successful, definitely we have to make sure that our agreements will yield positive net benefits to all potential participants. In this case, when we talk about the environmental problems, so every country should do self-enforcement, because we know that everyone will get a higher benefits if, let's say, we do cooperations. So research suggests that many treaties tend to codify action that countries will have taken anyway. So definitely we will have little net improvements. And definitely enforcement has been very difficult because we are dealing with many countries and we are trying to reduce the same pollution, right? If, let's say, we are reducing the pollution, we will incur costs. But if someone else has not reducing their pollution or has not been doing their abating, so they will enjoy the benefits of better environmental quality when we have doing the abatement. However, clever treaty design can actually lead to cooperations. In this case, if, let's say, the least cost instruments can be used, so should be easier to achieve positive net benefits for all participants. This is my favorite part, which is to ask you a question. So how to ensure the members' commitments after signing the international environmental agreements. So in this case, when they have signed the agreements, how to ensure that they will change their behavior, how to ensure that they will do the abatements, because definitely we cannot enforce people, we cannot enforce the country to do what they have agreed or what they have promised. So how to ensure that they will commit after they sign the agreement? So think about it, and we will discuss it during the class time. Performance bond. These are actually payment made to an appropriate authority, and it is only returned if the country complies with the agreements. In other words, we also call it as deposit refund schemes or environmental assurance bonding systems. So we can also use performance bond as one of the potential commitment strategy to help maintain the cooperation among the countries. So in this case, the country has to pay some deposit, okay, if they want to join the agreements. So if let's say they violate the agreements, or if let's say they didn't change their behavior, they didn't abate, so we will keep the deposit. So by breaking the agreement, it will become less attractive because we have kept their deposit. Okay, so although a large bond requirements might reduce attractiveness of signing up the agreement, definitely, but we can also think of it as one of the potential solution to maintain the cooperation, right? We can also give side payments. So the ongoing payments from some countries to others may actually help to make an agreement become self-enforcing and encourage other countries to join in. So in this case, we are actually moving from potential Pareto improvements to Pareto improvements. And we can also impose trade restrictions on the countries that don't comply with the agreements. So for the case of Montreal Protocol, they have the provision for this trade restriction. According to the US President Ronald Reagan, I'm pleased to sign the instruments of ratifications for the Montreal Protocol. The protocol marks an important milestone for the future quality of the global environment. However, another US President, George W. Bush, I oppose the Kyoto Protocol because it would cause harm to the US economy. So the first one, when we talk about Montreal Protocol, the United States President was actually supporting it. While when we talk about Kyoto Protocol, another president opposed it. So what is the difference between these two? Why the first president support, another one was opposing it, although they are talking about environmental pollutions. Based on the previous statements, let's have some discussion. Why was international agreements easier in reducing CFC, chlorofluorocarbons? This is the case of Montreal Protocol. Then in reducing greenhouse gases, this is the case of Kyoto Protocols. Why? The former is easier compared to the latter. So we will discuss this during the class times. What do you think about it? This is the milestones for the Montreal Protocol. This red line is basically refers to the natural emission released by the environment every year. This data refers to the ozone depleting sources like CFCs and other emissions. So we can see here that the emissions increase pretty quickly until the ends of 1980s. And when the protocol happens, or when the policies are putting into place, and afterwards we can see that the emissions have been falling. So it was a success because the emission has reduced every year until the future. However, this is not the case for the greenhouse gases because the emissions are still increasing even until now. It is easy to reduce CFCs compared to greenhouse gases actually. Let's start with the CFCs. The benefits of mitigations are very clear. For example, we can reduce the risk of having skin cancer. Second, the cost of mitigations is relatively low compared to greenhouse gases, because the CFCs have a substitute. So for those who want to use the CFCs, they can go for the substitute. Third, the chemical companies are also keen to produce the substitute because of the high demand. So high demand will definitely lead to high profit. Next, the monitoring process is easy because Firms who are using CFCs are actually limited in number. For example, fringe companies. Not all companies will use CFCs. Next, there is a high concentration in a small number of countries, for example, United States. So when we are dealing with a small number of players, it is easy to solve the problems. If you still remember when we discussed about game theory, so when we are having small number of players, it is easy to find the solution, right? And United States is also the country that producing the CFCs are expecting to have the net benefits for reducing the CFCs, and other countries are also expecting to have a positive net benefit. Okay, in the case of Montreal Protocol, payments are actually given to the developing countries who wanted to join the protocol, and they also gave punishments for the countries that are not willing to join the protocol in the case of trade sanctions against the company. So this is the kinds of punishment that the protocol has given to those who are reluctant to join the protocol. And because of these payments and punishment given, so it has an increased number of members to join the protocol. It is hard to reduce the greenhouse gases because it is more like a prisoner's dilemma. It is hard to reduce the emission because everyone has the incentive to free ride. If let's say your country is reducing the pollutions or your country is doing the abating, other country will get the benefits by doing nothing, right? So everyone is happy to free ride. Next, the number of polluters are very large. In this case, we are saying the polluters are dispersed throughout the world. Everyone is contributing to the problems. It is not like the CFCs that only the United States was contributing to it. In this case, even the agricultural sector is releasing the greenhouse gases. Next, fossil fuels are actually pervasive. Many countries have the stocks of fossil fuel, and fossil fuels is considered as an asset and it is profitable. For example, Venezuela have an oil stocks. Who else? UAE, Saudi Arabia. So this country will not reduce their consumptions of fossil fuels because they are making lots of money out of it. Next, equity issues are actually large share. Okay, historically, most emissions now are from the developed countries like Europe, United States, and Japan. So developing countries contributed relatively small share of the current stocks of pollutions. So currently, developing countries' emissions per person are actually lower than the developed countries. So if let's say the developed countries ask the developing country to reduce their current emission, well, the developing country may not be happy to do that because most of the share of the pollutions are coming from the developed countries, even though later on China and India will contribute more to the emission. Next, the time frames or impacts is actually long. If we reduce the CFCs, the ozone layer fixes fairly quickly. So in the case of the hole in the ozone layer is getting smaller and will become approximately zero in 2050. But in the case of greenhouse gases, it is a long-run problem. If we reduce our emission now, we will see the effects in 100 years or 200 years later on. So people may not be confident about it. Okay, next, the mitigations of the greenhouse gases are actually quite high, right? If let's say we are saying that we don't want to use the fossil fuel, is it possible? Well, people will face a lot of loss and many people may not be able to develop their country or may not be able to achieve economic growth. So the cost is actually quite high. So people may be reluctant to reduce the cost of using fossil fuel or to reduce the greenhouse gases. Okay, in the case of Kyoto Protocol, the targets met are actually less ambitious because the cost of mitigations is high. Next, there is no safe incentive because the free ride issues is rampant. And last one, United States did not ratify it. So why should other country wants to do it? Right. Okay. Let's discuss the case study of Canada in the case of Kyoto Protocol. Initially, Canada committed to reduce greenhouse gases emissions by 6% for 2008 until 2012 relative to 1990 level. And then Canada ratified the Kyoto Protocol in 2002. However, Canada's emissions increased quickly, partly due to unexpected fossil fuel boom. So the new government was not too interested in meeting the commitments, particularly as the United States hadn't ratified Kyoto Protocol and China and India had no commitments to reduce their greenhouse gases emissions. So Canada's emissions exceeded the Kyoto Protocol commitments by more than 20%. So basically Canada wanted to reduce their emission by 6%, but then they have exceeded by more than 20%. So because of that, Canada faced financial penalty for exceeding the Kyoto Protocol commitment. So in 13 December 2011, Canada formally withdrew from the Kyoto Protocol. For an international environmental agreement to succeed, participants need to have incentive to first ratify it, second change behavioral policy to achieve the agreement's objective, and the last one, not leave it like Canada. In the case of Kyoto Protocol, dividing emission quantities between countries in a rigid way is a difficult task to do because there are many countries that are dealing with. Right, so it is hard to just divide it in a rigid way between them. Next, we could squabble forever. So some country will question about this division if let's say they are a small country, while a larger country will also keep complaining about the amounts that they have to reduce. Right, so we will keep complaining forever. Next, if there is a global emission goal, a looser target for one country will have to be matched by a tighter target for another. So we call it a zero-sum game. Next, it is also difficult to commit to a target when there is so much uncertainty about the cost of abating and how a nation's economy will evolve like Canada. Next, we also will face with the equity issue. So developing countries have refused to participate in dividing up a fixed emission budget because they will keep complaining, saying that, well, the current stocks of pollutions are coming from the developed nation. So why should they actually reduce the emission now? So should they really participate in reducing the emission? So they will refuse to do that. Next, if we ever agree, we might not implement our agreement, right? And if we fail to reach our commitment, we could just pull out like what Canada did, right? Because there is no enforcement, no international or global governments to impose the penalty on us. Okay. Alternative approach to Kyoto Protocol. It is not a perfect either, but at least we have something here. All countries agree to implement certain policies rather than agree to each achieve emission targets. For example, international agreements about setting carbon prices. So price-based approach perhaps is better compared to Kyoto Protocol because it would be least cost in terms of emission reductions. Second, if countries agreed, they could actually reduce the emissions and collect tax revenue, and this tax revenue can be used to reduce the other tax, and we call it double dividends or perhaps green tax reforms. So could this approach be self-enforcing? Definitely many countries may not like it, but at least when we have more alternative, well, it is better than having nothing. Next, we can also use technology-based approach. So perhaps you want to increase the solar usage or increase the use of renewable energy. Perhaps this approach is more attractive by other countries because they can focus on the green technology, they can have a good investments to reduce their pollution. Right, so there would still be disagreements and arguing among the countries, but perhaps there is more chance of long-run success. Okay, for your information, Warwick has spent a lot of time to do his research on price-based approach. If you want to know his research in more detail, you can just refer to these works. Okay? Can we achieve the least cost global abatements of greenhouse gases? So mathematically, in order for us to achieve the least cost method, the MAC, marginal abatement cost for all polluter, should equal to each other. So in this case, it is very unlikely the MAC will be equalized across all sorts of pollution. Definitely it is almost impossible, and it is very difficult to achieve the least cost method because of free riding issues, sectoral coverage, and there might be arguments over responsibility, who should abate more and who can emit more, and so on. And how can we actually set a price or global carbon price since there are different types of emissions? So basically it is hard to achieve the least cost method in the case of greenhouse gases, definitely.